All right, just remembering that there are different ways to do the same integral, and I'm just doing one of them. So, or maybe two of them. Let's see. So the first one, we've got the integral of 0 to 4, 1 minus x all cubed dx. If I look at the 1 minus x, if it was just u, it would be u cubed, and that would be easy to do. So maybe over here I'll just say let u equal 1 minus x, or let's think about it, then du equals negative 1 dx, so negative dx. So if I had a negative here, then I'd have the negative dx, which gives me the du. So I might put a negative here to balance it. All right, so really that's just having the f dash of x on the outside, allowing us to do it. If I was using u's, I couldn't put the same limits because the limits 0 and 4 correspond to x limits. What I could do though is go and just say, oh well, this so negative dx here gives me du, so I can say 1 minus x, which is u, so u cubed du. I could just leave them off, and then when I integrate, what I could do is wait till I've put the x's, so let's put the quarter outside, let's put the x's back, so this is 1 minus x to the power of 4, and now I'll put the limits back in. That's a bit of a cheat way to do it. Alright, so some people will do that in their mind, so they don't need to do the substitution of u. But I like to write it down sometimes, makes it easier. So let's put 4 in. 1 minus 4 is negative 3. Negative 3 to the power of 4 is 81. And 1 minus 0 is 1. And 1 to the power of 4 is 1. So we end up with 80 minus a quarter times 80, which should be minus 20. All right, so that's one way to do it. Let's look at B. So for B, if we look at the bottom and the top, you can see we've almost got the f dash of x on the top. If we look at the bottom as f of x, so we've got 1 plus x cubed on the bottom, and if I differentiate that, I get 3x squared. So if I just put a 3 there and put a 1/3 out the front, we could change it. So it's 1/3, and then because I've got f dash of x on f of x, that's just a log, right? So look for the fraction. So that's log of the bottom. All right, there it is. And it's a definite integral, so I'm actually going between 0 and 1 for x. Now when I do that, so I don't need the third inside, I keep it outside. When I put 1 in, I get log 2. When I put 0 in, I get log 1. So there you have a third of log 2 or log 2 on 3, just using log laws. Either way. All right, let's have a look at C. So for C, you can see it comes straight off the reference booklet. It's an inverse tan, except the bottom for the inverse tan has a squared plus an x squared, and this one has a 3x squared. So what we need to do is get factorized by that 3. So if we pull that 3 to the very outside, so now we're good, we've got x squared. But the 1 there needs to be factored in as well. So in order to do that, so now I'm timesing it by 3 and I don't want to times it by 3. So, and I want it to be squared. So if I do that, there I've got my a squared. So my a is 1 on root 3. So now it should be easy because it's in the form we want for inverse tan. So remember, for inverse tan, be a little bit careful. So first of all, we've got the 1 on 3 out the front, and we want to put the 1 on a out the front. So we've got we end up with a root 3 on 3, and we've got inverse tan of x on a. So again, it becomes root 3x. All right, so it's a little bit difficult to see because of so if you think of x on a, and a is 1 on root 3. So if I did divided by 1 on root 3, that's the same as times by root 3 on 1. So I just get root 3x. So just be a little bit careful there when you've got a fraction for your a value. All right, so when we look at this now, we've got root 3 on 3, inverse tan of root 3. I'll write it down, inverse tan of root 3 minus inverse tan of root 3 times 0 is 0. All right, so we know that inverse tan of root 3 is 60 degrees. Remember, we're in the first quadrant and the fourth quadrant. And inverse tan of 0 is 0. So we just get our root 3 pi on, oops, that should be 60, so that's pi on 3. Sorry, that should be pi on 3. So that should be 9. There we go. So we get root 3 pi on 9 as our answer for C. All right, let's have a look at D. So for D, if we look at again, it's a fraction, and when you've got e to the 2x on both top and bottom, remember the derivative of exponentials kind of stays the same with a little bit out the front. So if I differentiate e to the 2x plus 1, I do get the e to the 2x, but I need a 2 as well. So what we can do is put a little 2 there and a half out the front to balance it. So what we've got there now is a half, and then we've got f dash of x on f of x, which is a log. All right, so we've got log of the base, so e to the 2x plus 1. And I don't need absolute values there because e to the 2x is always positive. And we're going between 0 and 1. All right, so let's have a look. So here we've got log of, I don't want that. All right, log. If we put a 1 in, I get e to the power of 2 plus 1 minus log of, if I put 0 in, e to the 2 zeros is 0, so e to the 0 is 1, 1 plus 1 is 2, so we get log 2. And you can use your log laws here. So we're going to get, oh, did I put a half out the front when I should have put a 2 out the front? Yes, I did. Sorry. So remember when let's just check. 2, I'll have to check that. But at the moment, so I got a half log. Hopefully there's not an error, but there may be. So that's just using your log laws. All right. Okay, so let's just do E and F. Get rid of this one. All right, looking at E, I've got 0 to 1/3. So again, it's square root of a 2 squared minus a 3x all squared. We could actually do a substitution, or you can just rearrange it so that it looks exactly like the reference booklet, the one with the inverse sign. So if we do that rearrangement, what we can do is put a 1/3 out the front. Why is it 1/3? Because that 9 under there is if I factorize by that 9, really I'm factorizing and pulling it out of a square root, so it becomes a 3. So it's a little bit tricky because of the square root. But so that 4 is the same as 2 squared, and now we are also dividing it by a 3 squared. And now we have an x squared, so that's all good, and it's dx. All right, so that looks like the reference booklet now for inverse sine, and it would be x on a, and a is 2 on 3, so it becomes x on 2 on 3, so 3 goes to the top. And we're going between 1/3 and 0. So let's have a look at that. So when I sub a 1/3 in, I get inverse sine of a half. When I sub 0 in, I get inverse sine of 0. All right, that's nice. So inverse sine of a half is 30 degrees, so that's pi on 6. Inverse sine of 0 is 0. So we should get pi on 18. Hopefully that is correct. Okay, and the last one. So don't forget to, you can go slower, you can stop, you can pause. All right, so the last one as well, if I look at the bottom, it's 1 plus tan x, and I know if I differentiate 1, I get nothing. If I differentiate tan, I get x squared, and that's at the top. So straight away, we already know this, it's a log, and it's a log of the bottom. So what's at the bottom? The bottom is 1 plus tan x. So the integral is a log of the base, and it's between pi on 0 and pi on 4. So first we want to sub in pi on 4. Now tan pi on 4 we know is 1, so we're going to get log 2. And then I want to sub in 0. Tan 0 we know is 0, so I'm going to get 1 plus 0 is 1, so I'm going to get log 1. Using your log laws, you know that is just log 2.